Welcome to this course module. We learned a lot of things about React, and we already also saw some errors in our React application. Now, no matter how good of a programmer you are going to hit errors, either error messages or most of the time worse than that, logical errors. Now, in this module, I will show you how you can debug your React application, how you should read and understand React error messages, because a lot of them are actually quite good and helpful, and how you can then create a React application which is error-free. Let's dive into this and let's learn the various techniques you have at your disposal to understand and handle errors. So let's dive into error messages in a React application. In the project we worked on thus far, in the name changed handler, I'll add an error. In the code there, where we assign person, the updated person here, we reach out to event target value to get the value the user entered. Here where I assign the value, let's say we're not accessing event target, which is correct, but event input, which is incorrect. But let's say we made this mistake. Now, if we go back to the application, on the first look, it seems to work. If we toggle the person, it still works. But if I start typing, we actually get an error. And in our development workflow, we even get a nice display of the error here in the middle. Now, let's focus on the error message on the right. Always scroll up all the way to the top to see the error message. And there you see cannot read property value of undefined. You also get a hint at where this occurred in name changed handler, app.js, line 27. And it's displayed even nicer here in the middle. You get it highlighted, event input value. So this line seems to be incorrect. And there is no value property on undefined. Now that simply means the part prior to value, so this part here, is undefined, which is the case because there is no input property on event. Now you still need to figure out the target is correct on your own, for example by looking into the event documentation. You can look into the normal HTML input event documentation, but you get a clear clue about what went wrong and where. Now sometimes error messages are less helpful than this one is. Even if the error message itself is cryptic, most of the time you should get a helpful line number, which allows you to go back into your code and try to find out what's wrong about this line. This should be helpful and should allow you to fix the value. This is how you react on React error messages. Don't get afraid, don't panic. Oftentimes, these error messages are really useful. You should read them and you should have a look at the line numbers they point you to. Now, what about logical errors though? Let's have a look at these in the next lecture. In the last lecture, we had a look at error messages, certainly important. But oftentimes, you have logical errors, which are even harder to spot. You don't get an error message, but somehow it's not working. Let's say in the name changed handler, when we find the index of a person we want to update. Let's say we compare user ID with ID. And this is incorrect. The person has no user ID property. It will not throw an error though, because user ID is undefined, but you can compare undefined to something. You probably just won't find a fitting person. So if I save this code, by the way, I of course fixed the error from the last lecture. So if I save this code and we go back to the application, if we now start typing, we don't get an error, but I can type as much as I want. It won't update. I don't even see my updated value here because I broke the two-way binding because I'm not correctly updating the name of this person. Now, what can we do in such a case? We can walk through our code step by step. For that, I recommend using the Chrome Developer Tools. There you can go to the Sources tab. In the Sources tab, you will find your code structure shown under localhost. There you will find a source folder and you actually find your code here. Now, this is possible due to source maps which are generated. Basically, you could say translation files allowing the browser developer tools to go into your code as you wrote it and allow you to debug that code, even though the code which is shipped to the browser will be a different one, an optimized and bundled one. This is pretty cool because you can debug the code you wrote, even though it's not the code running in the browser. So in there, we know something's not working when I type here. And as we wrote the code, we know that the name changed handler is getting fired when we type. So let's place a breakpoint by clicking on a line number here. And let's start typing again. I typed one character and it's now pausing this. You see it's adding this I because that's the default behavior of the HTML element and we haven't executed all the other code which would overwrite it again. And now we can use the normal Chrome debugger tools here to walk through our code. And here we can step into the next function call to step into this find index function and understand what's happening there. So now inside there, we can have a look at the data we have available there, like the P object. Now we see this is for Max. This is the object it's currently looking at with find index. And we have an ID of ASFA1. We also see that this expression here is undefined though. And we compare this to an ID of ASFA1. So whilst this should match this person, which has this ID, since we access user ID, we can see it's undefined. And we can clearly see that user ID is not a valid ID because if we hover over the person again, we see there only is an ID object, no user ID object. With that information, we can now exit this process, go back to our code and fix our logical error. So using the Chrome debugger tools with source maps which are generated for you automatically is a powerful feature for detecting logical errors. You can walk through your code as you wrote it, even though that's not the code running in the browser. So that's a cool tool you should be aware of for finding and fixing errors, using the developer tools with the sources tab where you can access your original code due to source maps. Now you learned how to read and understand error messages and how to find logical errors. Sometimes you want to know the current state of your React app, and whilst you might be able to figure that out with the developer tools, it can be inconvenient. Thankfully, there is a cool extension you can add to Chrome, the React developer tools. Let's install it together. You can simply Google for React developer tools, and you will find the GitHub repository where you can learn more about them, how to use them, and can even contribute to the project. Or you head right to the Chrome Web Store. No worries, these are free. In the Chrome Web Store, I already added them to Chrome, but you can click Add to Chrome if you haven't done so. Once you added them, you probably need to restart Chrome, and thereafter in the Chrome Developer Tools, you can choose React. This new tab should be available now. There, the cool thing is, you now see your React app as you created it. If you click Toggle Persons, you see something which differs from the normal Elements tab you have though. You don't just see the DOM elements, you see your components too, like the person component here, or the app component. And down there at the bottom, you also see props and state of that component. So for the app component, you see the persons array. And if I click on a person and remove it, this is updated too. So now here you can see your state. You can also change it there. And for the person component, you see it doesn't have a state, but it has props and which props these are. You can also highlight updates so that you see, highlighted here, what changed in your code, like the addition of this class name, for example. So that's pretty cool too. It allows you to quickly understand the state of your components of your app and manipulate it and give you some insights you can't easily get with the normal developer tools, because it goes beyond showing what was rendered. It shows you what's behind the scenes, what's under the hood, basically. Thus far, you learned a lot about how to handle errors and find out what the state of your application is. Now, sometimes you have code which might fail at runtime, and you know that, but you can't guarantee that it always works. In this case, you probably want to show a nice screen or at least a custom error message to the user. Let me show you a constructed example. Let's say that when we render a person class, we actually have a chance of getting an error. So I will create a random number with math random. And if random is greater than 0.7, so we got a 30% chance, then I will actually throw a new error, something went wrong. And this should not be in the return statement, but in the function body. Now with that, we should sometimes get this error. Let's try this out. Let's save this component and let's toggle persons. And it immediately failed. So we saw this error. Because we have 3 components, we have a 30% chance on each component. It's not that unlikely. Sometimes it should succeed though, like in this case. But again, sometimes it will also fail, like here. Something went wrong. Now, of course, here this is constructed, but in a real application, you might indeed have some code which runs some operation, reaches out to some web server, which can definitely fail, and you can't guarantee that it does not. Would be nice to then at least catch this error and handle it graciously. For this, I will create a new component, and this is a new feature which was added with React 16. I'll name it error boundary, because you can create so-called error boundary components there. I'll name it error boundary there too. The name is up to you though. It's called error boundary, the concept, but you can name this component whatever you like. Here, I will create a class, error boundary, and I will extend component. So I need to import both React and then with a named import with curly braces, component from React, like that. So we're creating this component just as we created the app.js component. In there, I want to render something and I will return something. I will simply return a h1 tag where I say something went wrong, like this. I only want to return this if we got an error though. So I will add state, one of the reasons why we have to use a class here, and set my state to has error false. I'll also store an error message here, which is an empty string. Now we can add a new property, or new method I should say, component did catch. This is a method which receives a potential error and some additional information passed into it automatically by React. And component did catch will be executed whenever a component we wrap with the error boundary throws an error. I will show you how to use it in a second. First of all, let's complete the logic here. In there, I want to set the state because we now got an error. I will set has error to true, and I will set error message equal to the error, which should be that message. Now in the render method, we actually have 2 possible outcomes. Either our state has an error. In this case, I want to return something went wrong, or to be precise, I can't even render the error message. So this state error message. Or in the else case, I return this props children. That's important when accessing props in a class component. You need to add this in front of it, just as you did with state. So now this props children is whatever we wrap inside of error boundary. This should be our default case. But if we get an error thrown by something we wrap inside error boundary, this method here will fire, and has error will be set to true, and hence we can return this. Now let me simply export a default. Let me export this error boundary component, and let's now start using it. I'll use it in the app.js file and wrap my person with it. So I'll import error boundary from /error boundary, that folder, and in there the error boundary.js file without the file extension as always. And let's now wrap our person with it. So here in the list where I return person, there I actually want to wrap it with error boundary, just like that. Also after the closing tag of person, error boundary. Now, error boundary is a so-called higher order component. It's a component which simply wraps a component with the goal of handling any errors that component might throw. In the case of error boundary, that's its job. Now, with the person wrapped with error boundary, we also have to move the key here to the error boundary, because this is now the outer element which we map, and the key always has to be on the outer element in a map method, because that's the element we actually replicate. Now with that, let's save this, make sure all files are saved, and go back to the application. Now if you toggle persons until you get an error, you still see that error in the middle here, unfortunately. Now that only happens during development mode. Once you build this for production and ship it to a real server, it will not overwrite your page like this. Instead, what you will then see is, you will see whatever you render inside your error boundary, like the error message or any other default message you have. This does not mean that you should cluster your whole application with error boundaries. Only use them when it makes sense. So basically, only use them if you have some code you know that it may fail. Don't wrap any other code, because if normal code fails, you as a developer probably made a mistake during development. Only use error boundaries for cases where you know that it might fail and you can't control that. Then this might be a nice tool for production to show a custom error message and not have the whole application fail. Because the React application will then actually still work fine, and only the problematic component will be replaced with your custom error message. So error boundaries, a nice tool to know, not a tool to use anywhere in your application. And therefore, starting with the next module, when we dive back into this little example project, I will also remove it again to not wrap this. I will also remove my custom error source here to simulate this error. This is only for this module. In this module, we had a look at how we can read React error messages, that they can be quite helpful, that we shouldn't get shocked if we see them, and that we should always check the line numbers we see in the error messages. You also learned how to debug logical errors with the help of source maps and the Chrome developer tools, where you can place breakpoints and go through your code. You also learned how to use the React dev tools to get insights into the state of your application. And you learned how to use the error boundary here to wrap code which might fail at runtime, which you can't prevent, and then show a custom error message or some fallback page or content. Don't overuse them, but with all these tools, you should have a rich tool set to create hardened and safe and well-working React applications.